Hey, good morning, everyone. So I'm pleased to be here to present you some applications and how relevant are Sentinels for the wave forecast. So the Sentinel missions are operational missions, and in the framework of these operational missions, there is a very strong component for the wave forecast, operational wave forecast, and in this context, we are using Sentinel to improve the sea state forecast in the assimilation process, and this is important for the safety of people and goods in open ocean and also in the coastal area. You can see an example here on the bottom of this slide. It's the flooding induced by the waves near the coast in storm events. And the second point I want to mention, it's really important to improve our wave submersion warning by using data assimilation and Sentinel wave data. The second point I want to mention is Sentinel will improve also in the frame of the assimilation in the wave models, will improve the wave product from the MFCs. And this is good for users, and not only for use in wave product, and also for applications by improving the boundary conditions for local and coastal applications. The third point I want to mention in the goals, it's important to think in the future years that we are moving to coupled systems, and wave data from Sentinels will enhance the impact on the fluxes between the ocean and the atmosphere, and the waves will play an important role in this layer. So rapidly, the wave system, the global wave system from the MFC's CMEMS MFC, it's basically based on updated physics since last year, and 10 kilometers globally, which is really incredibly nice. And this is used several forcing. We have forcing from ECMWF, 3-hourly forcing. And also we have a surface current forcing from the ocean the ocean systems from CMEMS. And we have a nice assimilation systems which combining between altimeters and also wave spectra from the SAR. The altimeters, actually, we have 5. It depends if Jason is already recovered or not yet, and 6 with including Sentinel 3B since 7th May, after dedicated studies, which I will show here, of the improvement induced in the interleave orbit. And the assimilation, as I mentioned, used the Sentinel wave spectra from the SAR provided by the wave mod in the S1A and 1B. So we have two components of the wave application in the frame of the Sentinel. The Sentinel 3A and B gives on the right side the significant wave height, and this is important for the assimilation in several MFCs. We have several products, L2, L2P, L3. So now actually in the global we are using the L2 provided by UMedCast. We have also Sentinel 3A last year used from the TAC waves in the level 3. And it's important to mention that also this altimeter's wave height is important for the validation of the MFCs in terms of improving the wave physics, and also in terms of investigating some wind wave interaction and also wave current interactions in several regional domains of CMEMS. On the right side, it's Sentinel-1 data, which is basically based on SAR wave spectra. The SAR gives you the energy of the waves depending on the wave length and also the direction. And this is provided globally. As explained by Yanis, it's provided by the wave mod of the Sentinel-1 and the level 2. The global is using the wave spectra from this product. And also, I want to point out that the swell partitions provided by the level 2 are very important in terms of improving the swell dissipation physics in the wave models in the open oceans. So it has been demonstrated a few years ago when we implemented this ST4 physics from the paper of Ardouin et al. That it started from the SAR propagation, swell SAR propagation. So why it is relevant to use Sentinel-1 SAR wave spectra? I will start with this. This is important because we have a very low pressure system in high latitude generating storms, and often the atmospheric systems underestimate or overestimate the wind, which is the forcing of the wave model. And fortunately, we have the SAR has the capacity of measuring the swell, which is the long waves generated by this storm. And this is an example here for a track in offshore of South Africa, and gives you the peak of the energy of the waves with the direction, with the wavelength. And such information can correct the misfit induced by the atmospheric system and improve the quality of the wave product provided by the model. Here an example of the swell wave height, just demonstrated for the case before. We have these corrections of the swell wave height moving to La Reunion Island and also Madagascar, all along the Indian Ocean, and it can stay efficient in the system for a few days. Another example of using the SAR, this is related to even we don't have any wave spectra near the European coast, but this figure shows to the left we have the difference of impact of the assimilation of the SAR, and to the right we have the long swell period, and over 12 seconds it means that waves are longer than 200 meters. And you can see here in the circles the area where the waves are longer, and we have a very strong impact induced by the assimilation of the SAR on the left side. So in this case, we can see that there are impacts here. Sorry. Okay. We are impact here of the long waves generated from the North Atlantic, which moves to the Arctic and in the Norwegian and the Scottish coast. What about Sentinel-3? We have, since the interleave, moving the Sentinel-3B to the interleave orbit, we have did some experiment for the winter of 2019, and this example shows the results of the assimilation and the validation with the independent data like JSON and SAAL. We can see on the left side, when we use Sentinel-3A and 3B, we remove the bias shown on the bottom without assimilation, mostly in the high latitude where there is the uncertainties of the wind, and also in the intermediate regions and the northern hemisphere, which is really a good thing. So this is moving to the normalized standard deviations. Blue is good and red is bad. And we can show that the assimilation is working perfectly with the more bluish color on the top bottom, on the top slide. Just rapidly, this is an example to show that when we use Sentinel-3A, we improve, and also when we add Sentinel-3B, we enhance the impact in the different ocean basins, in the high latitude, intermediate, in the tropics, in the red colors. So this is very important for our applications. We had also validation with the buoys. This is an example of February 2019, where we can see here, after the assimilation of Sentinel-3A and B, we have a very nice fit over the peak of storms. This is the Brittany buoy managed by METEO France and the Met Office. And very nice peaks are well captured when we use the Sentinel-3A and B. And we have a normalized standard index, which is low, 10% for the buoys. Another applications is when we use the synergy between Sentinel-3 and Sentinel-1. And this is an example of another application in terms of storm event, and in this case, which is Cyclone Joaninha. It's in 24th March, and we can see that the trajectory of the cyclone on the right side, and we have the impact this is an example of the impact on the mean wave period induced by the assimilation of both Sentinel-1 and 3, which shows that longer waves are moving until the coastal area of the India, starting from the track line of the trajectory, which is indicated on the right side. This is an example to show, after validation, that it's in the QQ plot on the left side on the bottom. We have the red color when we don't use the assimilation of Sentinel-3A and B, and the blue one when we use the assimilation, and which shows that the blue colors line is close to the symmetric line, and this is very important in terms of range of significant wave height we correct in this area for between 4 and 7 meters. What is important for operational application is how the assimilation, how is persistent the assimilation in the forecast period. And this is an example when using the synergy between Sentinel-3 and Sentinel-1 of the reduction of the standard deviations in the analysis, and also moving on the lead time in the forecast in days. And we can see that the assimilation can stay efficient until 3 days with more than 3% globally. We have also some dedicated work in the MFCS to use Sentinel-3 data. And this is an example from the Arctic team from Patrick Boanger, which implemented a new filtering approach in order to use the wave data from Sentinel near the coast. And the filtering, it seems, working very well. And this is really interesting, and it can be used for others MFCs, which is very interesting for the application in terms of validation with the MFC's wave model. Other example is sensitivity work of the assimilation of Sentinel-3 implemented in the Med. Briefly, at the top we have the control run, and when we use the Sentinel-3, it's on the bottom the scatter plot, which shows that the fitting line is much better. I will skip this. This has been shown have been shown also by Yanis. This is the wave product which will be implemented in the futures, the level 3 by the TAC waves. And this is, I want to advertise here the wave reanalysis provided by the global system. This is really an outstanding reanalysis with some highlight with 20 kilometers grid size, 3 hourly forcing from ERA 5. We have in this reanalysis both Sentinel-3 and Sentinel-1 in the assimilation system. And we have also a forcing from surface current from the glorious reanalysis. And this is an example to show you how good this reanalysis will be, this reanalysis in comparison between the wave product from ERA 5 in yellow and the one given by WAVERYS, which is the reanalysis of CMEMS-Global. This is an example of October 2013, and we can see that the normalized scatter index in this month is significantly improved in different high and intermediate regions and the tropics comparing to the ERA 5. So we look forward to finish this reanalysis and to provide to the users such product. I think it will be very interesting to have a feedback from the users. Well, conclusion. So the global MFCs is now reaching a very outstanding scores in terms of accuracy of wave product. We are moving to roughly 9% globally of significant wave height standard deviation. This is mostly thanks to the altimetry and also the synergy of Sentinel-1 and Sentinel-3. This is really important to mention. Sentinel-1 and 3 helps also efficiently to provide an accurate wave product in storm events and during extreme events. Also, I mentioned here a case with the cyclone, which is important in the cyclone season in the Indian Ocean and also in the Atlantic. The other point I want to mention here in the conclusion, so then we are looking forward for the benefit of using upgraded altimeters wave product from the TAC waves and also from the Sentinel-1. There is a new processing for the Sentinel-1 wave mode, which will be processed soon by ESA, and we look forward also for processing all at the beginning of the mission of Sentinel-1 in order to prepare the next reanalysis, wave reanalysis, by using assimilation of Sentinel-1. So high expectations for all the MFCs for the tops because it concerns all the MFCs, Black Sea, Baltic, Mediterraneans. We need wave spectra in that area. This time we don't have it, so please take the message. Finally, check it out. So release of CMEMS-Global reanalysis, very interesting, and welcome for any feedback when it will be released on probably July or after the summer. Thank you.